Any two lines given any lines with a common endpoint, common limit, find the difference between the extreme endpoints or limits. It seems the whole mathematical world believes the lies of trigonometry. In formal geometry, we follow exactly what is implied in the elements of Euclid. An angle is a ratio. With what is given in the elements, one should be able to figure out the above problem, and one should then be able to write the simple algebraic equation for it. Let us review what is written. Every triangle is constrained by a circle. That is, the unit of measure for whatever you construct with a triangle is determined by the radius of the given circle as 1. In other words, every triangle is written up using a triangular coordinate system of reference with the radius always as 1. Secondly, each endpoint of the two extreme ends of a triangle resides in the opposite hemisphere of the other extreme. That is, one endpoint will be anywhere on one hemisphere, and the other point anywhere on the other, or they will occupy the same hemisphere, which means that in order to write the figure up, one can write it up for each result, producing two very similar equations, or one can incorporate a logical operator in the figure and equation, resulting in a single equation. As you can see in MathCAD, there are not many steps to the equation, and that is why I freely used results as fillers in the lines. Each step of the way you can refer to what is actually given in the figure. Trigonometry gives you a myth that you can only work with the right angle, when in Euclid, it shows you that any angle can be divided into two right angles, which lets you work with any angle whatsoever. As geometry is a system of grammar, it also has two, and only two types of identity, the arithmetic, and sometimes in an interactive figure value gets added or subtracted, producing what can be called a sine wave. However, it is also called a logical sign.
False words are not only evil in themselves, but they infect the mind with evil. Phaedo by Plato,